Okay, so let's work this this example here of the climber on the rope problem. And so what we're told is there's a climber bouncing up and down on a rope, so this will be part A. And we want to know what is the frequency with which he bounces up and down. And what we're going to do is we're going to assume that this rope obeys Hooke's law, okay, for its stretching while it's stretched. And so so the frequency is 1 over 2 pi times the square root of k over m. Okay, so we can plug these values in here. 1 over 2 pi. K is 1.4 times 10 to the 4 newtons per meter, which is 14,000 newtons per meter, divided by the mass of the person plus equipment, which is 90 kilograms. So you do that calculation, you get 1.99 per second. Okay, so about two bounces up and down per second. Okay, so that's part A. Now part B is a bit trickier. We're told that we want to calculate how far this rope stretches when the climber falls 2 meters before the rope starts stretching, before the rope comes tight. And so let's look at the situation here. We'll try to draw this over here. So the climber falls from 2 meters. Okay, so he falls that far, and then the rope starts stretching right here. So this is where the stretching starts, right there, and then the rope stretches further until we're at the rope is fully stretched and the climber stops. So the climber stops here. Okay? And we want to figure out this distance x here. How far does the rope stretch in stopping the climber? Okay? So that's how we're going to set this up. Now, so basically, we're going to take this height is 0. Okay? And therefore, this height is x. Okay, and that's what we're trying to solve. How far does the rope stretch? And the climber falls 2 meters before the rope starts stretching. So this is 2 meters here. So therefore, this point up here is x plus 2 meters. Okay? So there's the setup for the problem. Now, this is basically a conservation of energy situation. Okay? The energy at this initial situation here, so we'll call this the initial situation, okay, is equal to the energy at this middle situation, so we'll call this middle here, which is equal to the energy at the final situation, which is when the climber finally stops. Okay? So we really don't need to consider the middle situation at all. All we need to do is equate the energy here to the energy here. Okay? So the initial kinetic energy plus initial potential energy is equal to the final kinetic energy plus final potential energy. Okay, so initial kinetic energy is 0. So that's 0. Now what's our initial potential energy? Well, the rope has no role here. The rope only has a role when it's stretching. So here the potential energy, initial potential energy, is entirely gravitational potential energy. So that's mg times x plus 2. Because that's our height, y x plus 2. And that equals the final kinetic energy. Climber stops here, so this is 0. Plus 1/2 k. So the final potential energy, the gravitational potential energy is 0, because the height here is 0. but the rope is stretched by an amount x. So that potential energy is 1/2 kx squared. Okay, this seems like it might be an easy problem to solve, but this is a quadratic equation. And so basically this becomes a fairly tricky thing to do. So when we plug in the numbers here, remember mass here is 90, okay, G is 9.8, K is this 14,000. Okay, you plug those numbers in, do a bit of algebra, and you get a quadratic equation that's not so easy to solve. It's 7,000 x squared, so that's what you get from this. And then once you bring this over to this side, you get minus 882x minus 1764, and that equals 0. Okay, so this 82x 1764 comes from multiplying this out here. Okay, so that's a quadratic equation, and we need to use the quadratic formula to solve this. So remember the quadratic formula, and I'll erase some stuff up here. So when you have a quadratic equation like this, where this here is A, this would be B, and this would be C, the solution is x equals negative b plus or minus square root of b squared minus 4ac over 2a. Okay? So here's A, 7,000. B is negative 882. C is negative 1764. So you plug that all in here, do a little bit of arithmetic, and you find that x is negative 882. That's our negative b, plus or minus 7083, which is this square root of b squared minus 4ac, divided by 14,000, which is 2a, 2 times 7,000. Okay? Now, one of these solutions is going to be negative. The negative 882 minus 7083 is going to give a negative solution. We don't want a negative solution, so that doesn't make physical sense. We want to keep the positive solution because x is going to be a positive value. So we can cross out then the negative solution here. So that's not a viable solution. It's only the plus solution. And when you do that, you get the number 0.57 meters. Okay? So the rope stretches then, nearly 2 feet and bringing that climber to a stop.